Hey there, Mr. Sutton here with the AB Calculus 3-4 homework solutions on graphing derivatives. For this problem, we're trying to match these derivatives over here, or these graphs rather, with their derivatives over on the right side. So probably the easiest way to do this is figure out how many intercepts the derivative should have, and also whether it's above or below the x-axis. So for option 1, we see that we're changing direction one time here. There's a smooth turnaround here, so this is going to be one x-intercept. And then in terms of up versus down, we're decreasing initially and then increasing. So our derivative should go -0, positive. So let's look over on the right side and see if we can figure out one that does that. So I see here in option C, I'm negative, then I'm 0, then I'm positive. And this is the only option that has that particular pattern going on. So that's going to be option C then for this first one. Now for this next one, we have two smooth turnarounds. So that's going to be two x-intercepts in the derivative. So right away, that's probably going to be choice B. But just to look at the increasing versus decreasing, we're going up, then down, then up again. So it goes +0, -0, positive. And that's exactly the pattern we see here in choice B. So let's pick that one for option 2. Now for option 3, we have one smooth, well, it's not a smooth turnaround, but it's basically a derivative of 0 or close enough to it. Yeah, it doesn't actually look like it ever turns around and it gets to 0. So this is actually, it's an intercept, but just barely. So we'll say one x-intercept there, just barely. And then we're +0, and then positive for the derivative because we're always increasing. So that's going to be above the x-axis the whole time, except for that one little maybe it hits. So that would be choice A. So for this problem and the next 3, we're using these 4 answer choices here and trying to match our function with one of these 4 choices. On this first one, we have a constant positive slope. So that's going to be, and it's specifically 1. We can actually read it off the graph. So that's going to be choice B, because this is a constant positive function here. On this problem, trying to match this function with a derivative over here, we notice that we have a negative slope, then 0, then positive. So that's going to be, let's see, going from negative to positive, that's this straight line here in choice D. On this problem, trying to match this graph with its derivative, we notice that the slope here starts out and is always actually positive. It starts out very positive, almost infinitely positive, and then it tapers off. So the function closest to that would be choice A. We're starting very positive here and then getting closer and closer to 0, but never quite getting there. So slope always positive, smaller and smaller, choice A. On this problem, trying to match this graph with its derivative, we have a slope of -1. Then at this corner here, we're actually undefined, and then our slope jumps to +1. So that's going to be, let's see, -1, +1, undefined in between, choice C. For this problem, we're trying to sketch the derivative of this graph. Since I have a whole bunch of just straight lines, I'm going to have a whole bunch of horizontal-looking derivatives. And since we have all these corners, we're going to be doing a lot of jumps to get from one horizontal to the next. So let's see, our first derivative, looking at this first segment here, we have a slope of, we're going over 4 and up 2, so that's a slope of 1/2. I'm going to put a solid dot here at the endpoint, but then I'm going to have an open dot right here where we switch slopes. So horizontal line going from here to here. And then we abruptly jump to a slope that is negative. How negative? Well, we're going down 4 over 1. So this is a slope of -4. And actually, looks like these are just going by 1s, but a slope of -4 would be all the way down here, actually. So we're going over from here to here. And then we switch to a slope of, this is actually a slope of 0. So we're going from here to here with a horizontal line of 0. And then from 4 onward, 4 to 6, we have a slope of, let's see, this is going up 2 over 1. So that would be a slope of 2 as we get to that endpoint over there. To graph the derivative on this one, let's first pinpoint our smooth turnarounds here, places where we cross the x-axis on the derivative. So we have a smooth turnaround here. That gives us an x-intercept up there. Another smooth turnaround on the original gives us another 0 for the derivative. And then just mapping out the signs of f prime. So we're decreasing initially, so that's negative. Increasing gives us positive. And then decreasing again, we're negative. So we start out below the x-axis for the derivative. We go above and then back below, so this parabola-looking kind of situation there. To graph out the derivative for this one, let's first put a 0 on the x-axis for the smooth turnaround right here. So our derivative is 0 right there. We know this. And now looking at the signs of f prime, we have increasing for the original function, so that's positive f prime. Then we're turning to decreasing, so that's negative. So we're starting out above the x-axis for the derivative, and then crossing it and continuing to be below the x-axis afterwards. So that might be a line like this. To graph the derivative on this one, let's first put x-intercepts wherever we have a 0 slope. There's only one place that happens, right about here. And then before then, if we're looking at the signs of f prime, we were positive because the original function was increasing. We're also increasing for f afterwards, so f prime is still positive. So then we're starting above the x-axis for f prime, hitting the x-axis right here, but then going back above the x-axis, so probably a parabola is the best representation. To graph the derivative on this one, let's first notice places where the derivative changes positive to negative, or could, critical values. So we see here that the original function does not turn around anywhere, but it does have this asymptote going on at x equals negative 3. So that's going to give us an asymptote on the derivative as well. If we have infinite slopes involved, we need an asymptote on the derivative. Now let's take a look at the signs of f prime before and after this asymptote. We notice that the original is decreasing until we get there, so f prime then is going to be negative below the x-axis. The original function is still decreasing afterwards, so another negative for f prime. And now let's go ahead and try and graph it. So if we're decreasing, that means, or we're negative rather for f prime, that means that we're going to start below the x-axis and we have to approach the asymptote. The only way we can do that is if we start up here, which makes sense because we have a slope of close to 0, and then just kind of approach it sort of like the original function. So f prime and f are going to look pretty similar. They might actually look exactly the same. Who knows? It's going to look like roughly like this, though. We're sketching, not accurately graphing it. And now for the derivative on the right side of this asymptote, we're negative below the x-axis still, and it's a very negative slope if you look up here. So it makes sense that our derivative would start all the way down here with more negative numbers, and then our derivative should be approaching 0 as this original function gets less and less steep. So we're going to be approaching the x-axis from below now, like so. And there's our derivative. To figure out the derivative graph on this one, we're going to start by graphing out critical values. So on the original function, we have this smooth turnaround right here at 0. That gives us 0 for the derivative, so I'll put a dot on the x-axis there. Checking out the sign of f prime, we are decreasing on the original, so f prime starts negative. Then we're increasing on the original, so f prime is going to be positive. And one other thing to take note of as I graph this is that my slope, my f prime, is starting out pretty close to 0 on the ends here. So I'm going to be close to the x-axis. Then as I get more and more decreasing for a while, I'm going to have to come a little bit below and then go back up as I approach 0. Then I'm going to have to come up a little bit and come back down as my slope gets closer to 0. So something like that would be the most accurate representation. On this problem, we're given the graph of f, and we want to figure out the graph of f prime, the derivative of f, based off of that. So one quick way of narrowing down the field is looking at smooth turnarounds in f, because those are going to give us x-intercepts in f prime. We have 1, 2 smooth turnarounds, and looking at our graphs here, choices A and B are the only choices where we touch the x-axis twice. So C, D, and E already we can eliminate. Looking a little bit further here, we see that we are increasing on the original function at x equals 0. That means that f prime is going to be positive above the x-axis at x equals 0. So that's enough to narrow it down to choice B.